Hey everybody, this is your chapter 10. It's essentially your practice test, so the section 10.1 summative assessment review. So we're starting out here trying to figure out if what is shown here is or is not a polynomial. So you have to remember all of your rules about polynomials. So this kind of goes along with like the first page of your notes, where we identified all of the different rules. So one thing we have to remember here is that with polynomials, exponents can't be negative. So the fact that this right here has a negative exponent is a problem, right? That's an exponent of -7. And so this is not a polynomial. And the reason for that is we cannot have negative exponents. All right, moving on to the next one. Now we've got 17x minus 9x squared plus 2x to the fourth. If we look at this one, there are no negative exponents, which is a good thing. There are no variables on the bottom. There are no square roots. There are no exponents that are fractions. Those are all of the rules that we have to remember. There's a fifth one, but I can't think of it off the top of my head. But regardless, this one is all good. This one is a polynomial. And so for this, we don't have to write anything here because we only have to write if it's not a polynomial. Ah, there we go. That's the rule that I was missing. This one is not a polynomial because of this right here. So that fifth rule that I forgot about when I was just talking about all the different rules is that we cannot have an exponent that's a variable. So this is not a polynomial, and we have to write that the exponents cannot be a variable. So when we look at our exponents, they have to be positive whole numbers. They cannot be x's like this one is. That would give us an exponential function, and that is not a polynomial. All right, here we've got another example. So we have to look and decide if this breaks any of the rules. And we can see that there is an x inside of a radical, a variable inside a radical. So this is not a polynomial. So we could say x cannot be inside the radical. And remember, the radical is that square root symbol that we're talking about. Now, you do want to be careful, just as a quick side note, because if this was written as negative 9x squared plus the square root of 7, and then the x was outside the radical, this one would be a polynomial. So you want to make sure that you're careful about where the x actually is. Is it inside the square root or not? If it's inside the square root, that's not a polynomial. But if it's outside, that's okay. Here we need to rewrite the polynomial into standard form, which means we know it has to go in order from the highest exponent to the lowest, and then we're going to answer the questions that come along with it. So if we look at this polynomial, the 9x to the third has to come first because that's the highest exponent, and then minus 13x. So if we take a look at this, the number of terms that there are is 2, right? There are two separate pieces that we're looking at here. The degree means what is the highest exponent. So if we take a look at this, the highest exponent here is 3. And then we need to classify this. So we need a first and a last name. Remember that your first name talks about the degree of your polynomial. And then your last name talks about the number of terms. So when we look at this one, for the first name, we need to look at the degree. In this case, the degree was 3, and so we know that that is a cubic polynomial. And then the last name is always the number of terms, and we were given 2 terms in this one, so this is a binomial. So when we look at the first and the last name, this is a cubic binomial. For the next one, for standard form, we look out. This is already in standard form because it's only 45x, so that's all we have to worry about. There's only one term here. Degree means look for the highest exponent. So when we look here, the degree on that x is a 1. Even though it's invisible, there's still a 1 there. So the degree is 1. And when we think about the first and the last name, so first name needs to be in terms of the degree. So if a polynomial has a degree of 1, we call that linear. And then the last name deals with the number of terms. There's only one term, so this is a monomial. Standard form for this one is going to be negative 4x squared plus 6x minus 13. This polynomial has 3 terms. It has a degree of 2, so this is a quadratic since it's a degree of 2, and then trinomial. Oops, sorry, I kind of ran out of space there. Let me erase that. I'm going to write trinomial underneath. Sorry about that. All right, so quadratic because it's a degree of 2, and trinomial because it's 3 terms. All right, standard form here is going to be x to the 4th minus 9, so it's actually already in standard form. There are 2 terms. The degree is 4 because that's the highest exponent. Degree of 4 means that it is a quartic. And since it's 2 terms, this is a binomial. All right, the directions here say find the sum or difference. Don't forget to write your answer in standard form. So since this is an addition problem, we're going to be finding the sum. And we know that when it's an addition problem, we get to just drop the parentheses. So it's x squared minus 5 plus 8x, and then plus negative 2x squared plus 11 minus 9x. Now all we have to do is combine like terms. So I can see there's an x squared and there's a negative 2x squared. So when I put those together, I get negative 1x squared. And then we have 8x and we have negative 9x. So 8 plus negative 9 is going to be negative 1x. And then finally we have a negative 5 and a positive 11. So that's going to give us positive 6. And so there is our final answer. You can go ahead and write the ones in front if you want. That's totally fine. And then don't forget there's a calculator up here that you can use to actually do your work if you need to when you combine those like terms. Okay? This one, we can see that there is a negative sign here, and so we're going to be finding a difference since we're doing a subtraction problem, which means we have to distribute this negative inside the parentheses. So we rewrite the first one, 6x squared minus x. That doesn't change at all, but we can drop the parentheses. And then we distribute the negative inside. So minus 2x cubed plus 5x squared, and then minus x. And now all we have to do is combine like terms. So if we look, this is the only one that has an x cubed. So negative 2x cubed is going to come first. And then we've got, let's see, 6x squared and 5x squared. So if we combine those, we get plus 11x squared. That's a really bad 11. There we go. And then let's see, we've got a negative x right here and a negative x right here. When we combine those, we get negative 2x. So there is the difference that we found. That's the answer. Here we've got another addition problem, so we can just drop the parentheses. So it's 13x plus 2x squared minus 12 minus x cubed plus 13x squared minus x. We don't have to write this plus a negative right here. We can just make it into a minus sign right there. And now we just need to combine like terms. So let's see. Negative x cubed is going to come first because that's the highest power. And then we've got 2x squared right here and 13x squared right here. So that's going to be plus 15x squared. And then we have a 13x right here and a negative x. So 13 minus 1 is going to give us 12x. And then we've got a constant right here, negative 12, and that's the only constant, so just minus 12 at the end. And there's our final answer. And for the last problem, this is another difference. We know that because of this negative sign right here. So we're going to go ahead and distribute the negative inside the parentheses first. And so it's 2x cubed plus 11x squared minus 3x. The first parentheses just stays the same. And then we're going to change the signs on all of these. So plus 3x squared plus 3x minus 7x cubed, and then plus 19. And then we just combine our like terms. So 2x cubed and negative 7x cubed is going to give us negative 5x cubed. And then 11x squared and 3x squared is going to give us 14x squared. Negative 3x and positive 3x. Well, those actually cancel each other out, and we're left with no x's at all. And then we've got a constant right here for plus 19. And so here's our final answer for that one. All right, if you guys have any questions, please be sure to send either me or Mr. Howley an email. Your test will be posted on Thursday at 10 o'clock. So any questions you have need to be asked before then. Thanks for watching.